Okay, so we are moving to the next topic. In the today's session, we'll be like discussing about production function and process. Okay, so far we have been discussing about what is the demand, supply, how equilibrium occurs between these 2 points, and then what happens to the elasticity of the demand and elasticity of supply. Okay, so now we'll be like moving on to the next concept, production function. Okay. So, what is production? Actually, it's nothing but a process where you convert your inputs into outputs. You given inputs, which can be raw materials. So, people working in the factory like work on the process with the machineries and stuff, and then they give the output. For example, if it is a textile manufacturing unit, so you'll be like giving the threads, and then the people will be in processing, and then maybe they'll be like giving out a shirt, right? So it involves a process where all the inputs, which is nothing but your raw materials, is converted into the outputs. This is a process which creates value, or it adds value to the existing product. It creates an utility, a complete product, or it adds some value to that particular utility. It extends a product or a service. So it can be anything. Okay. So for some examples of inputs are nothing but your land, labor, capital, and technology and other raw materials. Okay. You need a land to set up a factory or construct an office. Then you need people to work for it, and then you need investment, and then you need technology, all the infrastructure, I mean IT infrastructure and the raw materials. Yes, output would be like any product that you manufacture. So example, we were talking about shirt, yes, or a soap, or a car, or it can be software, right? Whatever it is, when it is like finished out and come out of the factory or a company for the clients or customers use, you call that as a output. Okay. So there's a function called production function for this. Actually, this function explains the relationship between the inputs and the outputs in the process of production. Okay, so it says here Q is the production function of A, B, C, D, E. When you see here, Q is a production function of A, B, C, D, E, whereas A is nothing but your land, B is your labor, C is your capital, D is your organization, T is your technology, and it goes on. So based on the number of factors that you have in this function, you can just like add it according to the business scenario you are in, and then you can create a production function. Okay, it's just nothing but a complete relationship between the inputs, which are the factors for the production. uh, so we can see the relationship. Okay, so we'll be like discussing about two different laws here. Okay, so we just like discussed what is land, labor, capital, and organization. Okay, so before we going into the theories or laws, we have to understand what are the inputs. Okay, so the two different kinds of inputs: fixed inputs, variable inputs. So fixed inputs are the inputs which will like kind of never change over a period of time, whereas variable inputs change over a period of time. So you have land, labor, capital, organization, organizer, technology. These are the inputs, right? So here when you see land, it most of the time it is fixed. Okay, the amount you spend on buying a land, it's actually fixed cost. Whereas when you pay salary to your employees, that is your variable input. The money that you invest, it's a fixed input. Okay, it's going to remain the same at least for a period of time. But the salary for employees will change according to the number of employees that you like employ, and you don't have to give them in bulk. You just have to like pay them every month, whereas like in fixed inputs you pay it in bulk at one shot during the first time. Okay, so the fixed inputs remains the same in the shorter period, and at any level of output this remains the same. Okay, so if this fixed inputs will most of the time will never change, at least for a short period of time. Okay, the cost of these inputs are called as fixed costs. Okay, the money that you have been invested in the land and like building, you can call that as a fixed cost. Okay, over a period of time, if you are like buying a new land to open your second unit, you have to build a office as well, factory as well. That becomes your run. I mean, your fixed input, but it varies. But it might take some time, at least like 2 3 years to like open a second factory after establishing your first factory, right? So it might take a certain period. So when you see the variable outputs, so in the longer run, this factors of production varies according to the outputs. I mean, for example, if I have to manufacture 10 shirts, I have to employ one employee. Maybe if my demand is like saying I need 30 shirts, so I have to employ at least three employees, right? So it based on the output volume, this factors vary. So the cost involved in this like variable inputs are called as variable cost. So the labor, raw materials, this kind of varies based on the demand. So this becomes your variable input. Okay, so a few concepts in the production is total product. So when you say total product, the number of products which is manufactured is called as total product. Okay, so average product. So average products is nothing but a ratio of the total product and the one variable input. Okay, in the denominator, you'll be having a one variable input. I mean, we'll be discussing based on the two laws that we'll be discussing all this later. So don't get confused. Just understand the formula. And marginal product is rate of change of output to the rate of change of one variable input. Okay, so just like discuss this, I'll show you a table where we'll be calculating the total product, average product, marginal product. Okay, just understand this concept. Yeah. So in this table, we can see labor, which is kind of increasing from 0 to 10. Capital is increasing from, sorry, it remains constant. I mean, it's K, and total output, it's actually kind of increasing. So if I'm employing one employee with fixed cost of 10 rupees, I'm producing an output of 10 products. So if my labor is kind of increasing, so over a period of time, when I employ 10 people, I was able to make 100 products, right? So the number of output you give, number of products you manufacture is called as the total output. Okay. So what is average product? So when you divide this total output with the labor, with the variable factor. So here we see the labor is the one which is kind of changing, which is a variable factor, whereas capital remains same. Okay. So here the average product is computed by dividing the total output with the variable factor. Okay, here the variable factor is labor. So 10 divided by 1. So here we can't do, because we can't do average product because there is no production is made, because there is no people employed, right? So here for 10 products, I was employing one person. So it was 10 divided by 1, it's 10. Here it's 30 divided by 2 because I had two employees. So it's 15. Here the 60 products are made with 3 laborers. So it's 20. 60 divided by 3, 20. It goes on. Okay. So when you compute average product, you have to like divide the total output with the variable factor. Okay. So marginal product is like computed by calculating the difference between the two total outputs. So here it's 10 minus 0, it's 10. 30 minus 10, it's 20. 60 minus 30, 30. Okay, so it's just a difference between the two total outputs. Okay, so when you see marginal product is kind of increasing, but here see it's kind of increasing, but it's kind of decreasing here. See, it's 80 minus 60, it's just 20. 20 products are only made more when I employ 4 people, whereas when I employ 3 people, 30 products are made from earlier. So it's kind of increasing, but you see when I employ 7 people, I'm manufacturing 112 products. When I employ 8 people, also I'm manufacturing the same. So it doesn't make a difference. So it's zero. But see, actually, this is little weird, right? So when I employ 9 people, this number, the production is decreasing. 108 minus 112, it's minus 4. It's kind of decreasing. So why do I have to employ more people? So actually this kind of calculations is used to find out how many people has to be employed in each of the firm or each of the process. Okay, so we'll be like discussing this now. We'll see a graph also here for this. Okay, so you see, um and you see the marginal product is kind of increasing. It went to 30 and then it is decreasing. And here you have the average product, it start increasing but it started decreasing. Average marginal product was went to negative. It's going negative, right? So where in the graph where this average product and marginal product meets is here's the point E. Okay. Okay, so based on this, we'll be like discussing about two different laws: laws of variable proportion and laws of return of scales. Okay, so laws of variable proportion applies when based on the short run production scale. So here we'll be just like having at least one input is variable. I mean, we discussed capital was fixed, the labor was varying, right? So we'll be like studying the marginal product and average product with by considering only one input is varying. So this happens only in the short run production, right? So this is actually called as law of diminishing return. Okay, so we'll see the explanation later. So in law of return scales, we will be discussing about what happens in the long run production function. I mean, here all the input factors are variable. So over a period of time, what if I'm going to expand my factory? So so which means I have to have my investments also variable, right? So here only the variable cost varies. Here the fixed cost also varies. So this will be like studying the situation on what happens in the long run production function over a period of 5 years or 10 years. What happens? So that is like called as law of return scales. So we'll be discussing each of these laws in detail right now. Okay. So as I told earlier, law of variable proportion actually explains us what happens in the short run production function. Okay, it's also called a short run production function. Okay, so here we'll be having at least one variable factor. Uh, Sorry, we will be having at least one variable factor variable, and then we'll have all the other inputs fixed. Okay, so let's see each of this. Okay, we'll see the table. I'm using the same example here, but we are categorizing this with uh, as a first stage, second stage, and third stage, and I've also included land. Earlier, we did not had land. Okay, here capital is fixed, land is fixed, but we have labor which is varying. All the numbers remains the same. So until 0 to 3, we are in the first stage. From 4 to 8, we are in the second stage. With labors 9 and 10, we are in the third stage. Okay, so in the first stage, you see the marginal product is kind of increasing. In the second stage, it is decreasing and it reaches 0. The third stage, the marginal product is negative. Okay, this is how you have to like categorize your short run production function into different stages. So when the MP is increasing to I mean, we'll be having it as the first stage. When it is decreasing, it should be the second stage. When it is like negative, it will be the third stage. Okay, so here you're computing the graph. Okay, between three different stages. Okay, here when you see the marginal product, it's actually increasing and it reaches 0. Sorry, reaches the maximum and then comes to 0 and then goes to negative. The same graph actually like we saw, because the numbers didn't change. Okay, so I was just explaining the different stages here. So first stage was the increasing return, and second stage was diminishing return because the marginal product is decreasing, whereas in third stage it's completely going negative. Okay, so what happens in the first stage? Actually here the total product is increasing at an increased stage. So at the end of the stage, it is the maximum in total. Okay, here The average product is also increasing, and it reaches the highest point at the end of the stage. Yes, but here the marginal product is increasing, but it becomes equal to the average product at the end of the stage. Here you will see marginal product is greater than AP. In the second stage, it's actually started decreasing. Here the marginal product becomes zero at the end, and the total product will be maximum when compared to the rest at the end. But here the marginal product will be less than AP. At the end, the marginal product will be less than AP. In the third stage, actually, it just the curve goes down. Here, the MP is completely negative, and total product is kind of decreasing, and average product is also decreasing, but it becomes positive because people are manufacturing products, right? So it will be like decreasing, but it's always positive. The total product is also decreasing, it will be positive, whereas marginal product will be negative. Okay, so if we like look into the table, you will be able to understand all this. It's just an explanation of what happens in the table. Okay, so where should a rational firm should produce? Whether they should be like producing in the stage one or stage two or stage three. Uh, I mean, where should be based on this? I mean, how do they determine the input factors? So let's see. In stage one, what's happening? Firm is actually like not making use of all the fixed factors because they have invested a lot of money in the land and labor already. Just because if they're employing less people, which means they're not using the entire capacity of the factory. In stage three, the marginal product is being negative, which means when I include more people, more employees, the output is decreasing. Okay, so here actually you should not be including more employees because too many people will spoil the broth. In stage two, actually is the right place where any firm should go in for production. Okay, but you can't say like at which point it should be like you should determine it actually based on the business nature as well as based on the production product curves as well. Okay, so to determine this you have to like know more about your input as well as output. I mean the number of money which is invested as well as like what is the price it is going to be selling. Okay, if it is a product which will be like having less inputs and being like sold at a maximum price, you can obviously like go for a higher number of labors. But if it requires a lot of employees who should be like paid more money, in that case you should be like kind of stopping in the first two segments, like with four or five labors. I mean when you see the second stage table, you should know that. Okay, so based on the situation you should be able to decide it. And then the second law is law of return of scales, return to scales. Actually this is also called as long run production function, which actually helps the firm to like how they should be investing. Okay, in the future. Okay, let's see that with an example. So I have only two factors here, labor and capital. So labor, when you see, it's kind of increasing from 2 to 18, and capital is increasing from 1 to 9. Okay, so total product, so number of products which is manufactured, and when we had different of factors. Okay, and the marginal product is also kind of increasing and started decreasing as earlier, but here it is not being, is going negative. Okay, so here we are just only using the fixed variable factors, fixed cost factors. Okay, labor and capital. So when you see the marginal product here, it is actually kind of increasing. So it is called as increasing returns to scale. Here it is constant. The number is kind of constant for a few rows. It is called constant returns to scale. Then it is decreasing. Okay, so let's see what happens. Okay, so you can actually like classify this into three different categories. So with a 10% increase in the input, if the output is kind of increasing 15%, I'm just like only increasing my input. I'm putting only 10% of more effort, but I'm getting output of 15%. So in that case, my return of scale is increasing. So it is called decreasing returns to scale. Whereas with the same amount of input, I'm getting the same amount of output. Yeah, that is constant returns to scale. But if you like give more input, but your output is kind of decreasing, so it is called decreasing return to scale. Okay. So when you see the graph, so here it's increasing. You have the slope kind of increasing and reaches the constant while it's kind of plateaued and then it goes down. So it actually shows us the increasing returns to scale, constant returns to scale, and decreasing returns to scale. Okay. So we'll see what is a homogeneous production function and heterogeneous production function. Okay. So when all the inputs are increasing at the same rate, at the same proportion, you call that as a homogeneous production function. When the inputs are increasing at a different proportion, for example, if land is increasing 10% and capital is also increasing 10%, you call that as a homogeneous production function. When your land is increasing 10% but your capital is increasing 20%, then you can call that as a heterogeneous production function. Okay. So here also you're having the same thing. Okay, increasing return to scale or decreasing return to scale and constant returns to scale. Okay, in a linearly homogeneous function, what happens here is like here the input factors are increasing in the same proportion as in the output. Uh, See, here we were just talking about the relationship between each of the input factors. So land is increasing 10%, capital is also increasing 10%, but the output is also increasing 10%. You can call that, when you have the constant returns to scale in homogeneous function, you can have call that as a linearly homogeneous production function. So that's why when the inputs are increasing for 10%, your output is also increasing 10%. We call that as constant returns to scale. So that is actually when you like draw the graph, you can see that it's a linear homogeneous production function because everything, including the factors in the output, is increasing. In factors of input and output are increasing 10% only. Okay, so when you just like draw the graph, you'll be just getting a linear line. Okay, so this is what happens when at 100 units of output. Okay, see here, this actually the line which shows the linear function. Here this is percentage of changes in the capital and this is the labor. Okay, we are not talking about land, so we are talking about a variable factor as well. So when this happens, you'll be getting the curve here for 100 unit output. For 200 unit of output, the curve kind of shifts to the right. Okay, when the quantity is kind of increasing, the curve shifts to the right. Okay, next one is isoquants. So isoquants is like when you have the same output for different levels of uh, variable factors, you can call it as an isoquant. Okay, so it's nothing but a possible combination of two different outputs. So with 20 labor and one capital, I'm making 100 units. With 18 labor and two capital, I'm making 100 units, which means I'm kind of like investing in making getting the process automated. So I'm trying to like when you automate the process kind of more by investments, so that I'll be able to employ less people. Okay, so wow, so the output remains the same because my demand is always going to be the same because I have only 100 people living in my city and only those 100 people drinks coffee. So yes, this is going to remain the same. My output is always, my demand is 100. So decrease the cost. So what I'm doing, I mean, I'm increasing the capital to go for technological advancement so that I can decrease my labor. So this is actually called isoquants. So when you see this in the graphical form, you can see a curve where when capital is kind of little higher, labor is less. Number of labor is less. Okay, you can see the relationship here for a different combination of two inputs. Okay, so when there's a constant returns to scale, okay, when all the factors, when all the input factors, when all the output factors are increasing at the same rate, this curves will be, these isoquants will be equally spaced. Where if you have this for increasing returns to scale, because when here to the, if you're like only like increasing the input by 10%, if you're like output is increasing 15%, here what happens, the isos quant will be like kind of very closer and they'll be like together. Okay, it will shift but not too much. But in the decreasing returns of scale, it will shift mostly, I mean, the shift is kind of little higher than the increasing return to scale, and the isoquants will be even more widely spaced than the other one. Okay. Next is MRTS, which stands for marginal rate technical substitute. Actually, here we will be like trying to understand the slope of the isoquant. Okay, so rate at which one factor of production is substitute with the other factor. If so, that is actually called as like slope or MRTS with you when you have the level of output as same. I mean, I just want to have only 100 units. I have only 100 people living in the city who drinks coffee. Okay, so my output remains the same. The rate of change of capital with my labor. Okay, so it's called MRTS. Okay, hope you all got this. So the slope of the isoquant is called as MRTS. Okay, so far we have been discussing about the production function, two different laws, isoquants, homogeneous function, heterogeneous function, and linear homogeneous function, and many more. Okay. Also, we discussed like when any rational firm should be able to produce. Okay. If you got any question, you can just like uh, keep me posted so that we can discuss. Okay.
Okay, ma'am.